So hello everybody, we should have by now been able to watch those two wee videos and the PowerPoint. So now we'll just do a few wee notes on pressure, which is on page 4 of booklet B. We'll begin with their definition. So often they would ask you for a definition as part of a question. Okay, so really what is pressure? Okay, and it's obviously pressure is a force. We're looking at all forces, and it's defined as that pressure is a force and that is exerted over a particular area, and we say that it's exerted per meter squared or centimeter squared. So we can represent pressure as a formula, and obviously pressure is a force and it's exerted over a particular area. And if we just look at our formula triangle, it combines of force, pressure and area. Okay, and obviously we have the ones below are being divided into the one above, and the ones beside each other are being multiplied. So we'll have a wee look at more detail of the units and stuff like that. So the unit of pressure is called the Pascal, after the scientist Pascal, and it's abbreviated to PA. So that's 1 PA, or what we would use is the newtons, which is unit of force, per meter squared. Okay, so you can use either, they can be intertwined. Most likely we'll see this one. Okay, so the newtons per meter squared. Now if we are using millimeters, then pressure would be newtons per millimeter squared. Or if we were using centimeters, then pressure would be newtons per centimetre squared. So it just depends what's being asked of in the question. But if you're stuck and you can't remember, and it's pressure that you know, P for pressure, P for Pascal. So you could just put PA as your unit. So we'll have a wee look now at some examples of pressure, and we've looked at those already in the PowerPoint. But the typical one is for a knife blade. So a knife blade has a small area. Okay. So even a small force, and you notice if you're cutting chips or potatoes or whatever, a small force creates a large pressure. Sometimes we don't want a small area to create a large pressure. We want the opposite, and we would see these mostly with tractors and rescue vehicles on mud flats and stuff like that. So flotation tires, okay, on a tractor, or tracks on a tank or a digger, they provide a large surface area. And so they exert a low pressure so that they don't sink into the soil. And then the classic one that I always remember from school is the drawing pin, and they're specially designed. A drawing pin is pushed on the end with the larger so that it doesn't hurt your thumb. Your thumb, sorry, feels a low pressure. But the point get into the board, the small end, exerts a high pressure. That's the same if you hammer a nail into wall. Okay, so now we're ready to look at some questions.